Hello, my name is Neil Gallagher, and this is one in a series of presentations uh, to discuss how to use your camera and how to do the lighting if you're interested in photographing models or in doing portraiture photography. This particular set of slides is about the camera exposure and how you set camera exposure modes based on the desired result you want to see in the photograph. Typically, with a modern DSLR camera, digital single lens reflex camera, you have a number of choices. You can choose full program mode, where the camera makes all the decisions. And while that will often give you a properly exposed photograph, sometimes it doesn't. The camera makes mistakes in looking at the scene, and sometimes even if the photograph is properly exposed, it's still not the photograph that you were looking for and hoped to do. If you can use shutter priority and the shutter priority allows you to set the speed of the shutter, and that's good for stopping action. So, for example, sports photography, you might choose a shutter priority setting. Aperture priority allows you to set the aperture on the lens, and then the camera will set the shutter. And you might use that priority if you are interested in controlling the depth of field of the photo. In other words, do you want, for example, the background to be in focus or out of focus? And then my favorite for portraiture photography is manual operation, where you choose all the settings by yourself. You choose the ISO, you choose a shutter, and you choose the aperture. And you choose these to give you very specific results in the final photograph. Okay, so what do these settings do? The ISO setting sets the sensitivity to the light for the camera sensor. And the higher the ISO number, the more sensitive is the sensor. For example, ISO 400 is twice as sensitive as ISO 200. In other words, 200 will require twice as much light to give you the same exposure as the ISO 400 setting. A shutter speed sets how long the shutter is open. When the shutter speed number displayed is 250, for example, what that means is that the shutter is open for 1/250th of a second. The f-stop or f number sets the size of the lens aperture for letting the light into the sensor. Here I show a graphical diagram representing a number of different f numbers. For example, f1.4 on the left all the way to f8 on the right. And that approximately, as we go from left to right, the size of the aperture is half of what it would be for the setting on the left. So, for example, f2 is half the aperture size for f1.4. The ISO setting. Now, today's digital SLRs have a very large range of ISOs, a range that would be envied by people who use film. The settings far exceed what was reasonable in the film days, and it's not unusual to find a camera that has an ISO range of 100 to 6400, for example. However, as you use higher and higher ISOs, that is, you set the sensor, you bias the sensor to be more and more sensitive to the light. You also make the sensor more and more sensitive to the electronic noise generated within the sensor elements itself, actually a result of quantum mechanics. So as you go to higher ISO settings, your image can become noisier and noisier, even to the point where it's unacceptable, as shown in the photo of the tiki dancer on the right. Usually, I set the ISO as low as possible. Now, not all the time. This isn't a hard and fast rule by any means, but I try to go for the lowest ISO setting that I can get away with, given other constraints that I might have on the image. Shutter speed. Shutter speed probably is the simplest of the three items to understand, the most intuitive. A setting of 500 on the camera has a shutter speed of 1/500th of a second. And of course, 1/500th of a second would let in half the light of a shutter duration of 1/250th of a second. So the 1/500th of a second represents how long is the shutter open and how long is it exposing the sensor. And you use a faster shutter speed if you want to stop action. Now, ISO. An ISO 400 with the camera and with a shutter of 250, for example, has the same exposure, lets in the same amount of light, given that the aperture is the same in both cases. ISO 400 with a shutter of 250 has the same exposure as ISO 200 and a shutter of 125, for instance. Now, here's the Sunny 16 rule, which was perhaps more commonly, broadly known in the film days, but it still can be useful today. But back in the days when people basically took manual photographs, was the only way that they did it without using the automatic and program modes. The Sunny 16 rule says that an approximately correct exposure will be obtained on a sunny day by using an aperture of f/16 and a shutter speed as close as possible to the reciprocal of the ISO speed. So, for example, ISO 200, aperture f/16, and a shutter speed of 1/200 will give you proper exposure. Then you might take a shot and then adjust the f number wider or smaller than f/16 to adjust what you find to be a pleasing result. Now let's talk a little bit about f number, and unfortunately f number means we have to do a little bit of math. First of all, as the f number gets larger, the size of the light gathering aperture gets smaller. So whereas with ISO, for example, larger ISO meant the camera was more sensitive to light, with the f number, as the f number gets larger, the camera becomes less sensitive to light. The light collection power is proportional to 1 divided by the f number squared. To compare the light collection power to f numbers, what I do, and there are other ways you can do it, but what I do is I take the f number, divide by 2, and then square the result. And if I'm comparing two f numbers, I do this for each of the two f numbers, and then divide one into the other to tell me what the relationship is between the light gathering power. So, for example, f/16, 16 divided by 2 is 8, 8 squared is 64, f/22, 22 divided by 2 is 11, you square that computes to 121. 121 is approximately twice 64, so what that means is f/22 has half the light gathering power of f/16. You don't have to divide by 2. What the important thing is that you do the same thing to both f numbers you are comparing. You either divide them both by 2 or you don't divide by 2. So I divide by 2 to make the computation of the square easier. Now, because 64 is about that, half of 121, we see that f/16 collects